Welcome to our capstone presentation. We are the mower, tow, detection, and change blade indicator team. My name is Nicole Komisaw.
I'm Sergey Frothman.
I'm Corey Bartlett.
And I'm Harper Klein.
The goal of this project is to overall increase the safety of Ryobi lawnmowers as well as help prolong the lifespan of the lawnmowers by creating a system to monitor the tilt, angle, and vibration of the lawnmower using sensors that feed into an Arduino microprocessor. The overall system design, we take input power from the battery, we convert that power to 12 volts and 5 volts. The 12 volts powers the microprocessor while the 5 volts powers the sensors and the relay. The microprocessor takes data in from the sensors. Based on that data, it signals to the user what condition the lawnmower is in. It also opens or closes the relay if excessive tilt or vibration is detected. The relay cuts power to the motor control board.
I just wanted to take a second to talk about the software state flow for our product. So in the start state, the Arduino is powered on when it receives power from the power converter. Afterwards, the sensors are initialized inside of the startup loop, as well as all other values needed for processing in the startup algorithm. Afterwards, if everything is set up properly, we move into our algorithmic processing that runs in a loop. In this loop, both the tilt sensor and vibration sensor are checked for high values, and if a value over the user-defined threshold is reached, first the user is alerted through the use of a status LED, and then the motor is stopped. This helps prevent injury and preserves the life of the mower.
The user interface subsystem consists of 3 LEDs. The green LED indicates that all systems are operational and that no excessive tilt or vibration is detected. The white light indicates that the motor has been turned off due to excessive tilt, and the blue light indicates that the motor has been turned off due to excessive vibration.
Our conversion subsystem intakes 20 volts to a DC-DC converter, and it outputs 12 volts and minus 12 volts. It outputs 12 volts to Arduino and the voltage regulator. The voltage regulator outputs the 12 volts to 5 volts to the sensors and the relay circuit. And the overall power board has a terminal ground screw.
I can talk about the sensor subsystem. So we're using 2 different types of sensors. We're using a 9UF LSM9DS1 sensor, which is a gyroscope, accelerometer, magnometer, and also a temperature sensor. We calculate our angles through Euler angles using both a gyroscope and accelerometer to avoid errors when vibrating. Our vibration sensor is a very simple piezoelectric sensor that we're using. It is connected to the relay, and then the DF sensor is also connected to the relay, and they both, if they're both tilted over their threshold, which is 200 for the vibration, and it's 45 for the angle sensor, the lawnmower is turned off. And that's how our sensor subsystem works.
The other output to our system besides the user interface is the relay subsystem. So this system was designed to approach the challenge of how do we turn off the motor without access to the control board. We came up with a solution of disrupting power to the motor. We brainstormed 3 possible solutions: a switching relay, a solid-state relay, and a power MOSFET solution. Why we used the switching relay was because we had relevant experience from other classes with this technology. The components on the board are limited to the relay, a Z-inner diode to protect the microprocessor from voltage spikes, an NPN transistor that allows the low voltage microprocessor control signal to drive the relay coil, and a 1 ohm resistor that lowers the current to the NPN transistor.
And then this is the total system design, which you will see more of in the demo videos. So as you can see, the lawnmower is powered on, so therefore our green light is turned on. Here's the rest of the circuit. We have the relay set up right there. The Arduino set up there. The accelerometer is there. I know it's kind of dark, so you can't really see it. We have part of the vibration sensor there. The actual vibration sensor is buried in those wires. And then we also have the power conversion stuff there. Now our lawnmowers, this is the over vibration test. So as you can see, it quickly realized it was vibrating too much. The blue light turned on, informing the user that that's why the lawnmower stopped. And then in order for the lawnmower to be reset, whoever is operating the lawnmower has to pull out the safety key, put it back in, and then it will reset and you're good to mow your lawn again. Okay, testing tilt on the lawnmower. Okay, so now the Arduino is turned on. Again, we have the relay circuit. We have our very nice accelerometer, which is going to do all the work, and the power board again. And as you can see, it is turned on green.
Like a flip?
Yep. So as we see, if we flip it at a 45-degree angle, it turns white. And now we're going to have to reset it by pulling out the key. As you can see, the light goes off, so therefore the circuit is off. Okay, we reset it. Okay. And it over tilted, yep. Okay, reset it one more time. And then this one does take a while, but it did reset.
Okay.
Okay, green light is on. We are going to start the mower and then we are going to tilt it. Can you actually start and tilt it? Because and it stops and the white light is on.